In this video, I'll be solving several problems where I find the derivative of functions using derivative rules, and I'll be calculating the first and second derivative of various functions. So for the first function, we have y equals minus x cubed plus 6. So to find the first derivative, we need to use our constant multiple and power rule. So for this first term, we'll pull out the minus 1. It comes in front. And then we need to bring down our exponent, or our power, of 3, and then subtract 1 from it, leaving x squared. And then the derivative of a constant is just 0. So our first derivative is minus 3x squared. And then to get our second derivative, we will pull out the minus 3 from up front. And then we need to bring down our exponent and subtract 1, but that will just be x to the 1, which is x. So our second derivative turns out to be minus 6x. Okay, so our next function, we have w equals 4t to the 5th plus 7t cubed minus 2t squared minus 3. So our first derivative with respect to t, we will use our constant multiple rule, bring out our 4. Then we need to bring down our power of 5 and subtract 1, leaving t to the 4th. Pull out the 7 in front of the t cubed. Bring down the third power. That goes down to t squared. Then we have a minus 2. We bring down our 2, leaving t to the 1st. And then the derivative of 3 is just 0. So this will leave us with 20t to the 4th plus 21t squared minus 4t. And then to get our second derivative, again, we'll bring out our 20 in front. Our 4 will come down from our exponent, leaving t cubed. We have 21 in front of our next term. We bring down our power of 2. T goes to the first power. And then we just have our constant multiple in front of t. So just minus 4. And when we simplify, we'll get 80 t cubed plus 42t minus 4. Okay, our next function, we have 5 times z to the 4th over 4 minus z plus 3e to the z. So for our derivative of y with respect to z, do our first term. So we get 5/4 out front. Then we do our power rule. So we bring down our power of 4. And then we need to subtract 1, so that goes to z to the 3rd. For z, we just have a 1 out front. And z to the power of 1 goes to the power of 0, which is just 1. Plus, bring out our 3. And the derivative of e to the z is still e to the z. So it would be just like e to the x would stay e to the x. And so if we simplify, our 4's are going to cancel in the first term, leaving us with 5z cubed minus 1 plus 3e to the z. Now if we find our second derivative of y with respect to z, again we'll keep our 5 out front, and we pull down our 3 from our power. And our z goes to z squared. The derivative of 1 is just 0. Okay, derivative of a number is just 0. Plus, we'll pull out our 3. And then again, just like in the first derivative, the derivative of e to the z is e to the z. So we're left with 15 z squared plus 3e to the z. Okay, our next function, we have y equals 4x to the minus 3 plus 1 over x. So our first term is pretty easy. We can take the derivative of it as it is. But the second term we want to rewrite so that it's x to some power. So if the x is on the denominator, we need to make the power negative to bring it to the top. So now we can take the derivative of each term. We'll have 4 from our first term, then bring down our power of -3, and that will go to -4. And then the second term, we will bring down our power again of -1, and x will go to power of -2. And when we simplify or bring all this together, we'll have -12 x to the -4th minus x to the -2nd. And I'm going to leave it in this form for right now so that I can get my second derivative more easily. So doing this, I'll pull out my -12 from out front. My -4 will come down from my power, and I'll need to subtract 1 again, so that will go to -5. Then I have minus, I will pull down my -2. My power will go to -3. Then I'll simplify. Minus and minus will be positive 48. X to the -5th. Minus and minus again will go positive, and I'll have plus 2 x to the -3rd. And now, if I want, I can simplify this by making my exponents positive. So that'll just move my x's to the bottom. I'll have 2 over x cubed. So in the second function, I need to do the same thing I did with the one on top, where I move my x to the top. So in order to do that, I will leave the number out front, make my exponent a negative exponent, so I'll go from x cubed to x to the -3rd. Do the same thing with my second term, so 4/5 x to the -2nd. And then my first derivative, leave 2/3 out front, pull down my exponent, subtract 1. The same for the next term, pull out my 4/5, my exponent of -2, go to -3. And then in the first term, my 3's will cancel. I'll have -2 x to the -4th. 2 and 4 will become 8. It'll go positive since there's 2 negative signs. 8 over 5, x to the -3rd. And then to get my second derivative, again, I'll pull out my -2. My -4 will come down from my exponent, and it will go down to a -5. I have 8/5 out front of my second term. I'll bring down my exponent of -3, and that will go to -4. And then I can simplify, so I'll have minus and minus will be positive 8 x to the -5th. -3 and 8 will be -24 over 5 x to the -4th. And if I want, I can make these x's go down. 8 over x to the 5th -24 over 5x to the 4th. Okay, so now that we've practiced using the constant multiple rule and the power rule quite a bit, now we can use our product and quotient rule. So the function that we have here looks like a quotient of two things. So our quotient rule for a function u divided by a function v is v u prime minus u v prime over v squared, or some people say low d high minus high d low over low squared, where high is, or u is your top function, in this case 4x minus 5, and low is your lower function, or the function on the bottom, which we'll call v, and in this case is 3x plus 7. And then in order for us to fill this out, we need to find the derivative of u prime, and the derivative of v, or v prime. Okay, and that will be u prime equals 4, and the derivative of v will be 3. So now we can just plug in to our formula for the quotient rule. So v, in this case, is 3x plus 7 times u prime, which is 4, minus u, which is 4x minus 5, times v prime, which is 3, all over v squared. which is 3x plus 7, and that will be squared. So now I'm just going to distribute my numbers here, 4 and my 3, see if I can simplify, and I'll get 12x plus 28 minus a 12x, and minus and minus will be a plus 15, all over 3x plus 7 squared. And here I have a positive and negative 12x, so those will go away. 28 and 15 will give me 43 all over 3x plus 7 squared. Okay, so our next function is s of t, so function s of t, 3t minus 5 to the minus 1 times t plus 4. So since we have this first term that is to the minus first power, we can rewrite it by moving it to the bottom and making the exponent positive. So that will leave t plus 4 on top with 3t minus 5 on bottom. And now we have our quotient rule, or we can use our quotient rule, getting this in the form u over v. So u, in this case, will be t plus 4, and v will be 3t minus 5. So our u prime will just be 1. Derivative of t plus 4 is just 1. V prime will be 3. And then we can write our derivative, ds of t with respect to t. And this is low d high minus high d low, all over low squared. So if we plug in, our v is 3t minus 5 times u prime, which is just 1, minus u, which is t plus 4, times v prime, which is 3, all over v squared, or 3t minus 5 squared. And now I can distribute like I did before. We'll have 3t minus 5, and then a minus 3t minus 12. I have a positive and a negative 3t. And this is all over 3t minus 5 all squared. So this will give me minus 17 over 3t minus 5 squared. Okay, in the next problem we have 3 times, in parentheses, square root of x plus 1 over square root of x. So the first thing we want to do is to rewrite this. So we can distribute our 3 and get 3 times square root of x plus 3 over square root of x. And then we want to write these radicals as exponents. So when you have a root, that will be a fractional exponent. So if it's a square root, it will be x to the 1/2. The root is always what's on bottom. And then the next one, we'll have to move it to the top and make it a fraction. So make it negative to bring it to the top, and then 1/2 because it's a square root. Now we can take the derivative term by term. We'll pull out the 3 in front, bring down our power of 1/2, and then 1/2 minus 1 is a minus 1/2, plus 3, again bring down minus 1/2 now, and then minus 1/2 minus 1 will be minus 3/2. And so now we can simplify and rewrite this. We have 3 over 2 times x to the minus 1/2 minus 3 over 2 x to the minus 3/2. And so now we can make these negative exponents positive by moving it into the denominator and then using the appropriate radical. So we'll have 3 over 2, and then this is a square root since it's 1/2 power, square root of x, and then minus 3 over 2. This is also a square root, but our x is going to be cubed because of this cube here. And then this is our final answer. So our next function, we have y equals 2x cubed times e to the x. So now we have a product of two functions of x. So if we can write this as u times v, then our product rule for this function is the derivative of the first times the second plus the first times the derivative of the second. Okay, so you just notice in one term you take the derivative of one function and leave the other function alone, and then you do the opposite in the next term. Okay, so in this case our u would be 2x cubed and our v would be e to the x, or you could just pull out your 2 altogether and multiply it by the whole derivative of the other two. But we'll leave it in for u for now. Our u prime will be 2 times 3x squared, or 6x squared. And our v prime, the derivative of e to the x, is just e to the x. So it's one of the easiest derivatives, because it's just itself. So now if we just plug into our product rule, we have 6x squared times v, which is e to the x, plus 2x cubed times v prime, which is e to the x. And then we make it simplify a bit. We've got an x squared in both terms, a 2 and an e to the x in both terms. So 2x squared e to the x. And this will be times 3 for our first term, and times x in our second term. Okay, our next function, we have y equals the fifth root of x squared plus x to the e power. So first thing we want to do is we want to rewrite this. So rewrite this radical. We have x squared, but it is under a fifth root, so it's x to the 2/5. And then plus just x to the e, we can leave that alone. So then we take our derivative, and we need to bring down our 2/5 from the power, and then our exponent needs to go down by 1, so 2/5 minus 1 is going to be a minus 3/5. And then for x to the e, we treat e just like it's a number, just like any other exponent, and we'll bring it down, and then it'll be times x to the e minus 1. Okay, so then we just need to simplify this first term. It's our x is to a negative exponent, so we will make it positive and bring it down. And then this is x cubed, but it's to a fifth root. So it'll be 2 over 5 times the fifth root of x cubed. And in the second term, we can leave it as is, since there's no obvious way to simplify. So our next function, we have y equals the cube root of x raised to 7.2 plus 3 times e to the 3.7. So we want to simplify this first term, but we can do it in a very special way using our properties of exponents. So if we have x to the power of n times m, this is the same thing as x raised to the nth power, and all of that raised to the mth power. So when you have an exponent raised to an exponent, that's the same thing as multiplying the two powers together, the two exponents together. And so we want to see if we can rewrite our x as something raised to the third power, and then our cube root will undo that power of 3. So 7.2 turns out to be divisible by 3. So we can write this as 2.4 times 3. This is a cube root. And I'll just rewrite this as it is, 3 times e to the 3.7. And now we can use this property of exponents and write this as the cube root of x to the 2.4 all cubed plus 3 e to the 3.7. Now this cube root is going to cancel out this cube, and we're just left with x to the 2.4 plus 3 e to the 3.7. Then we can take our derivative just like we normally would. So we're going to bring down our exponent, 2.4, and then subtract 1 from it. So 2.4x to the 1.4. And then our second term turns out to just be a number. E is just a number raised, and now it's raised to another number. And the derivative of a constant is just 0. So our answer just turns out to be 2.4 times x raised to the 1.4. Our next function, at first glance, you may think, oh, this is a quotient rule problem, but it can actually be much easier. So before you ever go to use a product or a quotient rule or any other more complicated rules, we want to see if we can rewrite our function in a simpler way so that we can use the easiest of our rules. So in this case, since our denominator is really simple, we can divide this up into multiple terms. So we can write this as x squared over x squared plus 3x over x squared minus 2 over x squared. And then we can simplify it further. X squared over x squared is just 1. Our x's are going to cancel. So this just goes to 1. One of our x's will cancel in our second term, leaving 3 over x. And then minus 2 over x squared. And so this, we can rewrite it again, moving our x's up. So 1 plus 3 times x to the minus 1 minus 2 times x to the minus 2. And we're going to go ahead and take the first and second derivative of this function. So why not? Derivative of 1 is just 0 plus, keep our 3 out front, bring down our minus 1, and then subtract 1 from our exponent. We have minus 2. We'll bring down our minus 2 from our exponent, make that go to a minus 3. And this is going to be minus 3x to the minus 2. Minus and minus will be plus 4x to the minus 3. And I'll leave it like that while I take the second derivative. So bring out my minus 3. Bring down my minus 2 exponent. That will go to a minus 3. And then plus 4. Bring down my minus 3 exponent. That will go to a minus 4. And I can simplify this. Minus and minus will be positive 6. I'll go ahead and bring my x cubed downstairs. Then I'll have minus 12 over x to the 4th. So for our last function, again, we have something that looks like a quotient rule in this first term, and then it's multiplying another term that's a function of x. So this looks like a quotient rule and a product rule. But again, before we do any derivative, we always want to simplify and see if there's an easier way. And so I'm going to take this first term and rewrite it like we did in the last problem as 1 over 4x plus 4x over 4x, that's just 1, times 4 minus x. And now if I multiply, I'll just get something that looks like a polynomial. And polynomials are really easy to take the derivatives of. So I'll distribute my 4 and my minus x. Okay, when I do that, I'll get 4 over 4x. So that's just 1 over x. And then 4 times 1, that's just 4. Minus x times 1 over 4x. My x's will go away, and I'll have minus 1/4. And then minus x times 1 is just minus x. So I could rewrite this as x to the minus 1 plus, if you wanted, you could combine these as 17 over 4 and then minus x. It turns out this middle term's not going to matter much because when we take the derivative of a constant, it'll just go to 0. But it's a little bit simpler to bring it together. So our first derivative, we'll bring down our minus 1 in the exponent, and that will go down to minus 2. Again, our derivative of a constant is just 0. And then in front of our x, we have a minus 1, and that power goes to 0, so the x goes away. And we're left with minus 1 over x squared minus 1. And if we want to take the second derivative, we can do that for our last function. We're going to have this minus sign out in front. We'll bring down our power of 2. Okay, so I'm looking at it in this form. That exponent will go down to minus 3. And then the derivative of both of our other constants are just 0. So we simplify this, we'll get negative and negative, we'll make a positive 2 over x cubed. So hopefully these problems helped you practice the quotient and product rule as well as the constant multiple and power rule. And in future videos, we'll get into more complicated derivatives using the chain rule and finding the derivatives of trigonometric functions.